This is class 2 lever activities. A little bit of a review for you. Class 2 lever has fulcrum. It has a load in the center, and the load is going in the opposite direction of the effort force that is on the other end of the lever. So the classic example of a class 2 lever is the wheelbarrow. So in this case we got a wheelbarrow and it's going to hold a load. So we'll move the lever out of the way and set it out here. And now we'll be looking at the wheelbarrow. Okay, and so the wheelbarrow's here. Now how much weight are we going to be carrying? Let's carry a weight of, let's load this puppy full of heavy stuff, 360 pounds. So what information do we need to know to be able to figure out the mechanical advantage of this wheelbarrow? The first thing we're going to need to know is how far is it from the fulcrum to the load or the force of resistance. So let's say that it's not very far at all. Let's say that there's only 2 feet, 24 inches, from the center of the wheel to the center of the load here. And then the next thing we need to know is how far is it to the handle. So we're going to say that along the bottom, from the center of the axle of the wheel to the handle, it's going to be 6 feet long. So now we can do our problem. We just simply need to do the formula f of e times d of e equals f of r times d of r. In this case, f of e is the unknown because that's the place here that doesn't have a blue number on it. So it could be any one of these numbers missing and we could still calculate it. So what we need to know is that the 2 feet and the 360 pounds go together, and the 6 feet and the force of effort go together. And everything that relates to the load in the basket here is related to the force of resistance. So we call that the moment of resistance. Everything that relates to the amount of effort we're going to be putting up on the handle, the 6 feet, and the effort force, that's the moment of effort. So let's stop and calculate what we've got here. So in this case, we've got f of e times 6 feet equals 360 pounds times 2 feet. So we have to do our math. We have to first move the 6 feet to the other side of the equation so that f of e can be by itself. So we're going to divide and we're going to factor out 6 feet from this side of the equation. So both of these will get a factor. Get my line here. Scratch through all of that. Both the number and the unit get factored out of that. On this side, we have feet on the bottom. We also have feet on the top. That's got to be factored out. And so we have some like numbers here. We have 6 and 360. We know 6 will go into 36 6 times. So what we can do is we can factor out the 6 from both sides. How many times will 6 go into 360? 6 times 10 is 60. Let me stop and do the math here. So what we can do is we can factor out the 3 and we end up with 6 will go into 360 60 times. So this will make our math a lot easier. We can get rid of that 3. 60 times 2. I messed up here. That line's not supposed to be there. 60 times 2. So the answer is f of e is supposed to be 60 times 2, or 120 pounds. So we can see the solution to our problem here is 120 pounds. We know it's pounds because the only unit we didn't use was pound here. Good luck.